Think about a rock the size of a potato, full of valuable metals, sitting 5,000 meters deep in the ocean where no light reaches and the pressure is strong enough to crush a submarine. Scientists made an amazing discovery. This simple-looking rock contains materials for electric car batteries worth more than $3 trillion. Countries are competing. Rich people are secretly funding trips, and scientists suggest this finding could change how we understand life on Earth. What they found deep underwater was better than anyone expected. The Clarion-Clipperton Zone, CCZ, is one of the last unexplored areas on Earth, located in the Pacific Ocean between Hawaii and Mexico. This underwater area, bigger than the European Union, goes down to 5,500 meters, where it's almost freezing, and the pressure is 500 times stronger than at the surface. Visiting this place is almost like going to another planet without leaving Earth. Companies have been interested in the area's valuable copper, nickel, cobalt, and manganese rocks for years. But in 2021, Dr. Andrew Sweetman's team from the Scottish Association for Marine Science came for a different reason: to study oxygen cycles in this harsh place where tiny organisms somehow live. They sent down robot landers with sealed chambers and tools to measure how microbes use oxygen in the deep mud. Something surprising happened. Instead of showing oxygen decreasing as tiny organisms used it up, the tools showed increasing levels. Thinking their equipment was broken, they fixed it, tested again, and sent new landers to different places. But the strange results continued. Oxygen levels were going up when they should have been going down. The team had to accept that something in this dark, deep place was breaking natural rules. After 5 years of careful testing on many trips, this finding changed everything. We've always known that making oxygen requires sunlight, so finding oxygen being made in darkness was like finding water burning. The team thought about unusual explanations: unknown mineral reactions, undiscovered chemical processes, a completely new form of life. The impacts go far beyond scientific interest. Finding oxygen production without sunlight challenges our understanding of deep ocean life and might explain how early life on Earth survived. It could even suggest possibilities for life on moons with oceans, but no sunlight, like Europa or Enceladus. The metal rocks miners want might be interacting with seawater in unexpected ways. Despite our advanced technology, the deep ocean still holds big mysteries. The seafloor was actively changing into complex, geometric shapes, perfect spirals like snail shells, grids with exact right angles, and complex patterns formed by connecting ridges. Adjusting his glasses, Sweetman said, "This isn't random erosion. This looks designed." More disturbing, comparing pictures taken hours apart showed the patterns were slowly changing, ridges growing, grids expanding, and spirals tightening as the seafloor reshaped itself. Time-lapse photography confirmed what they were seeing. "We're not studying rocks anymore," one team member said. Scientists realized they were watching Earth think in slow motion. The electrical data showed something stranger. Tiny changes in the magnetic field matched each pattern change, showing a hidden connection between shape and energy. The changes followed a rhythm. Energy burst, movement, then quiet, like a giant's heartbeat. The team ruled out all normal explanations: no heat signals, chemical traces, or currents. Physical evidence showed something was changing the seafloor through unknown processes. Most worrying, older maps showed these patterns had always existed, but were simpler before. This wasn't new. It had been growing unnoticed. And now that scientists were watching, the patterns seemed to change faster, as if responding to their observation. An unspoken question hung in the control room. Were they participants or merely observers? When facing unexpected findings, scientists look for logical explanations first. For the strange oxygen readings from the Pacific depths, tiny organisms were the obvious suspect. The deep sea has life in extreme conditions. Microbes live in dry soil, Arctic ice, and near boiling vents, many surviving without oxygen or sunlight by using chemical processes. So, when Dr. Sweetman's team detected rising oxygen levels in chambers at the bottom of the Clarion-Clipperton Zone, they naturally suspected microorganisms. To test this, they started new experiments to remove all life from their test chambers. They used biocides, substances designed to clean environments by killing microorganisms. This important step would show whether non-living processes were responsible. If oxygen levels still increased after removing all life, something else had to be causing it. The treated chambers were carefully lowered 5,000 meters to the seafloor. The scientists expected oxygen levels to stay the same or decrease without microbe activity. But when data came back, the results were history-changing. Oxygen levels in the clean chambers still increased slowly but clearly. Despite removing all microbe suspects, the phenomenon continued. This wasn't just broken equipment. The observation was consistent across strict controls and could be repeated in various settings. The scientists worked harder, repeating cleaning with different methods, changing chamber sizes and locations across the CCZ. The result stayed the same. Oxygen appeared where it shouldn't be. Dr. Sweetman's team worked with other experts, geologists, chemists, and marine biologists, comparing notes and historical data. Was an unknown chemical reaction between sediment and saltwater creating gases? The lack of biological explanation was troubling. After ruling out microbes, they faced a harder reality. They were observing a process unlike anything previously documented in seafloor mud. It was like chasing a ghost, yet the data was consistent. No matter how they changed conditions, removing life, changing pressure, modifying temperature, testing different areas, the pattern continued. Oxygen was slowly rising in chambers deep underwater. The team grew excited, realizing this wasn't a one-time thing but a widespread, reliable phenomenon needing new explanation. Beyond economic potential, what else might the seafloor be hiding? With no clear biological cause and traditional chemistry offering no answer, they kept working, driven by curiosity about what unseen force was changing deep-sea chemistry. A breakthrough came in 2022 when Dr. Sweetman heard someone at a deep-sea mining presentation casually call manganese nodules batteries in a rock. This casual comment stopped him cold. His team had been gathering puzzling data from the Clarion-Clipperton Zone for over a year. What if these lumps weren't inactive, as most scientists thought? Sorry for the interruption. Before we continue with the story, I kindly ask you to like the video and subscribe to this channel. It is very important for us. Thank you very much. The team knew salt water mixing with minerals can create small electrical currents. Their tests showed surprising results. Under certain conditions, their samples showed signs of tiny electrical activity. This changed how we see these deep-sea elements, not just metal deposits, but active players in their environment. This finding raised new questions about effects on strange creatures living in these areas, impacts on deep ocean chemistry, and possible consequences of mining these objects. The casual comment proved more accurate than anyone thought, reminding scientists that we're still discovering mysteries. We should completely understand these environments before changing them, as the deep ocean clearly holds many surprises. No team member was ready to make public guesses yet. The science was developing, and the phenomenon remained hard to explain. But what they had previously ignored as geological background suddenly became their focus. They had found a clue, not an answer, but it opened a new research direction. Later, in the ship's laboratory, hundreds of kilometers from land above one of the Pacific's most remote areas, something unexpected happened during routine equipment checks. The machines detected something unusual, a steady, low-level electric signal of about 1 volt. Though much less than needed to power a light bulb, it raised questions for scientists working thousands of meters below, where conditions are usually stable and predictable. Where did this 1 volt come from? There were no electricity sources nearby and no organisms big enough to make such a charge. No movement, no heat. It seemed like nothing should be making energy. The current, however, continued to stay steady. This wasn't a machine error. The team did many checks and even replaced equipment. The results stayed the same. Deep in the darkness, something was moving electrons in one direction. It was steady, slow, and quiet, like you wouldn't notice it unless you were looking for it. But it was impossible to ignore now that it had been found. The possibilities of just 1 volt were even more interesting. Even a small electric current can trigger chemical processes under the right conditions. That's basic electrochemistry. With enough time, even low voltages can greatly change the molecular makeup of a solution. That's how seawater makes metal rust. It's the process by which hot water vents create substances that support life. And it's the invisible way that energy moves across seemingly inactive areas. The crew couldn't determine what was initially causing this current. No moving parts were present. No biological sources like electric eels. No temperature differences. Nothing that fit the usual explanations. The environment itself seemed strange, or maybe self-wiring. Among the crew, there were talks of chemical reactions never studied in this environment, that might only happen under conditions and pressures 5 kilometers below the ocean's surface. The researchers didn't discuss the discovery publicly. They simply didn't know what to make of it yet. Not that they were hiding it. However, scientists believe even a tiny voltage in deep water may have huge implications. It suggested possibilities far beyond the current mission. What if energy were being produced naturally in ways beyond our current understanding? What if the deep bottom was more dynamic, more active, rather than just a graveyard of geological history? Suddenly, that 1 volt rising silently from the deep became the loudest signal of all. The secret of the breathing stones. Scientists have discovered one of nature's best-kept secrets in the deep Pacific Ocean. Rocks that release oxygen into the ocean without sunlight or living things. This is amazing and changes everything we thought we knew. This remarkable finding in the Clarion-Clipperton Zone, CCZ, a huge flat area between Hawaii and Mexico, is changing our understanding of how oxygen moves through Earth's most extreme places. Strange oxygen measurements from seabed tests in the CCZ confused marine experts for years. Sensors kept detecting oxygen levels mysteriously increasing within measuring chambers at depths greater than 5,000 meters, where sunlight never reaches, and pressures could crush a submarine. This made no sense because photosynthesis from plants or bacteria powered by sunlight is needed for all known forms of oxygen production. Here, however, oxygen was appearing where none should exist. Dr. Andrew Sweetman's team from the Scottish Association for Marine Science solved the mystery after years of careful study. The answer lies in potato-sized metallic nodules on the seafloor, nature's deep-sea batteries. These metal-rich nodules, which mining companies want for their valuable manganese, nickel, cobalt, and copper, are using their electrical properties to split seawater molecules. The process uses electrolysis, the same chemistry that factories use to produce oxygen and hydrogen. When nodules touch salt water under the intense pressure of the deep ocean, their unique metal composition creates microscopic electrical currents, just strong enough to split water molecules into their component gases, with oxygen slowly bubbling into surroundings and hydrogen spreading into the water. This dark oxygen production represents a completely new type of natural oxygen creation. Unlike the biological processes we've known for centuries, this is entirely chemical, a chemistry and physics process happening in nature's high-pressure laboratory. The implications affect many scientific fields. For marine scientists, it suggests deep-sea habitats may have oxygen sources we never considered, potentially supporting life in ways we don't fully understand. Astronomers are interested in what this means for the search for life on ocean worlds like Europa, where similar metal-rich seafloors might produce oxygen without sunlight. Geochemists must now consider this process when modeling Earth's ancient waters. However, this discovery raises serious environmental concerns about planned deep-sea mining activities targeting these exact nodules. The CCZ is the center of interest. If mining disturbs these natural breathing stones, it may accidentally change oxygen levels that deep-sea life has depended on for thousands of years, with unpredictable effects on one of Earth's remaining untouched ecosystems. Dr. Sweetman notes, "This isn't just about scientific curiosity. We've discovered a fundamental Earth function that was hidden in plain sight. We must understand it before we interfere with it." As research continues, these metallic deep-sea stones remind us how much we still don't know about our planet, and why our last frontier might be in the dark depths of our oceans rather than in space. The discovery forces us to rethink our basic understanding of the chemistry supporting life and the conditions under which it may survive. History rewritten. The basics of ocean research have been overturned by the discovery of dark oxygen. Research now shows that oxygen, essential for most life on Earth, can be made without sunlight, photosynthesis, or even living organisms. This chemical process has never been seen before in the deep ocean. Powered by electrical energy from mineral-rich stones, it's not just a scientific breakthrough, it's a revelation. If oxygen can form this way in Earth's most extreme and darkest places, what else might be possible? Mars, Europa, and Enceladus, previously thought unsuitable for life, may be more habitable than we believed. The problem is that the same metal-rich nodules causing this process are the target of the growing deep-sea mining industry. Companies like the Metals Company are working to collect these ancient rocks for their valuable metals, important components for building renewable energy infrastructure and electric vehicle batteries. This creates a serious dilemma. Could removing these nodules harm a natural oxygen supply we barely understand? Might we destroy ecosystems that depend on it before we even discover them? What started as a mission to monitor seafloor oxygen levels has turned into a race against time. Scientists now face pressure to learn more about this hidden system before it's destroyed or permanently changed. The deep sea, once thought to be a lifeless desert, is proving far more active and mysterious than anyone expected. 5,000 meters below the surface, in Earth's silent depths, we may have discovered the key to understanding life not just on Earth, but on other planets as well. What scientists found is amazing in every way possible, and what happens next is up to us. If oxygen can form in the deepest, darkest parts of our ocean, do you think it could exist elsewhere in our solar system? Did you enjoy this story? If oxygen can be created in the darkest depths of our oceans, could it possibly exist on other planets too? Share your thoughts in the comment section below. If you enjoyed this story, please hit subscribe and give us a thumbs up. We need to preserve what we haven't yet completely figured out. Thank you so much for tuning in. Catch you in our next video. Enjoy your day.